Yeah, so again, I am shocked at how short this class is, especially after having gone through material today. But we're essentially already halfway through class. So last week we looked at diffusion models in Midjourney. If you missed the class, that recording is available via the syllabus. So check that out. You won't really miss too much for this week because we're just going to pick up where we left off and kind of generate animations based on those Midjourney images, and then we'll do some stuff with deform today. So this week, we'll mostly be looking at like ways or concepts on how to sequence images, which I probably should have realized should be a thing we should do in this class, but it didn't really occur to me until the end of last week, like just how important that's going to be for us. So we'll spend the first half of the class talking about potentially sequencing images, whether you're doing it manually or whether you're using other tools, including machine learning models. And then we'll play with deform and make some really weird, trippy animations. We'll talk about more about deform later, but it's a really cool tool and basically like the way it works is pretty simple, but they've sort of packaged up into a nice little tool. So we'll play with that and make some fun animations. One thing to note for next week is please bring in a couple, 3, 5, 10, 10-second video clips. So if you have those beforehand, it's probably helpful. So you're not like scrambling to try to download stock video and crop things or whatever. I would say 10 seconds is probably the ideal rate. If you got 15, 20, that's fine. And I would probably recommend the video clips be pretty smooth motion. People dancing is a good concept. Nothing too fast because we're going to kind of turn these into stop motion animations. So you can kind of think like anything that moves fairly slow will look nice in a stop motion, whereas anything that's very kinetic and fast will probably look a little bit less nice as we make it even choppier. Yeah, so just bring those in for next week. No real limit to those. Yeah, and we'll look at a tool that'll basically like help us decompose those into videos into stills and then generate image to image from that. So I don't know if everyone got a chance to make animations. I made a couple. Um, Obviously, like not everyone knows how to generate animations from still images. So we'll look at that this week. This was the one I think I started demoing in class and I did finish it out. And this was just generated using FFmpeg, which we'll talk about a little bit more today. So you just feed an image sequence and it generates a video from that. If you haven't yet, and if you want to, please do share your animations, especially after this class where we actually make them. In the Slack channel, there is a thread where people can just share images and videos from these weeks. So it'd be nice to see more of those. I know Jake shared one of them. A couple people from the async class shared them. So you don't mind sharing them there. You just want to share your work to show people what you worked on. That'd be great to see. I did another one. One of the things that was kind of like, I knew we would do this concept for Midjourney, but I haven't really played with it too much. I kind of realized that I like using sort of the very and the subtle variations, the strong and the subtle variations together. So this one kind of uses like it does 4 frames of subtle change, and then it uses the strong change to basically change out the entire scene or whatever. So I kind of like this effect of like kind of bouncing between strong changes and using more subtle changes to get the animation. So again, I think there's opportunities and things to explore within Midjourney that we didn't even necessarily touch on. I also played a little bit of in painting, which I thought was fun. Allows you to sort of like manipulate people's mouths opening and closing, that sort of thing. So there's some cool options there. So this week we're going to talk about like basically we've generated all these frames. What do we do with them, right? So some of you might already have taken your images and dropped them into Premiere, After Effects, some other like GIF making tool, and that's all well and good. And I would definitely encourage you to use whatever tools you like to use. I'm going to show you a couple of tools that I use, which I admit I was trying to make this a code-free class or a command line interface-free class, which it will not be now with this session. But that's okay. Like, again, if you're not comfortable with these tools, don't worry about using them, but it's more like just to show you there are some options here to use. So before we get to that, I want to talk about frame rates. I assume many of you already know what frame rates are, but I just want to give a quick like overview on how this works. And especially with the concept of this class, like it's helpful to sort of think about what frame rates make sense for your animations. So obviously a frame rate is how many frames per second is shown. This is uh, especially during the analog times, it was really like how many physical frames were shown from a piece of film. In the digital world, we kind of think about it less as like individual frames, and it's more like it's packaged into a video. But frame rate is still quite important. And I think everyone here probably already knows this, but humans perceive a series of images as moving, despite there being actual gaps in that, right? So like in the case of these images, maybe these are not the best examples, but like our brains can sort of understand that we're looking at a woman potentially just changing poses. And then we see a little bit of animation between that, but it's not like we're seeing this as like a series of individual still frames, right? Our brain kind of like turns that into motion for us. And that's important to think about as we think about like what speeds are the right speeds, what speeds feel natural, how much change is too much change per frame, that sort of thing. So there are a couple key frame rates that, you know, we've sort of traditionally like sort of decided upon. So I'm actually going to start at the bottom and work my way up. 18 frames per second, which feels quite slow, but is still pretty reasonable for our brains to process. That's a common speed in film, used a lot for 8mm film. There were speeds slower than that, like 16, 10, that were done in like super old times, like silent film. And you know, those still exist, but they're sort of like a lot less common to see them. If you've ever seen like a really old silent film where someone looks like they're running really fast, it's because it was recorded at a slower frame rate, but then when it got converted to video or converted to some other format, it was sped up. So it was often shot at like 10 frames per second, and then someone turned it into a 24 frames per second video, and it like moves much faster. It was not actually intended to shoot at that speed. There were even hand crank cameras then that like have like weird variable frame rates because of a human having to crank it. 24 or 25 frames per second is the most common sort of film format. So it's 24 here in the US, North America, and it's 25 in Europe. And that's just a traditional frame rate for 35, 16mm film. So a projector will usually project at that speed. Somewhere around 30 frames per second, this gets weird and tricky, is a video frame rate. 20, you might see 29.97, 29.93 as video formats. Had a lot to do with sort of bandwidth of cables and that sort of thing, but it tends to be a little bit faster. And then now we're kind of in this world of 60 frames plus per second, and that is for video VR. One of the things people have found is that, you know, if you aren't showing sort of continuous frame rates at 60 frames per second after a while, like you get kind of sick to your stomach and other things. So a lot of games, or where there's a lot of fast motion, or you have a VR headset and you're kind of moving your head around. We kind of want 60 frames per second to be right for sort of human vision, essentially. So lots of people in the gaming world are interested in that. I don't know if anyone in the film, there used to be people in the film world who thought 60 frames per second was a good idea, and it's like we're all kind of like got given up on that idea because it's a little too crazy. And it makes motion look kind of weird. It definitely looks very different than watching a film. So those are the frame rates that like are traditionally used in common media types. The thing is, this would be quite a lot for us in animation, right? Like to generate that much material with that little bit of a change would be quite hard. And this is kind of why animators actually don't really use these frame rates either, although they convert to that when they finish their pieces out. So it's going to be more cost effective to not make animations at 24 or 30 frames per second. And it's also really hard to like have little stuff. If you like were to use Midjourney and then run it through at 24 or 30, like it would just be things like kind of like jittering or shaking as you look at them. So it doesn't really make sense to use those frame rates. In animation, we generally have like two other frame rates people will usually use, 12 frames per second and 8 frames per second. You might hear people describe these as on the twos or on the threes. It's called that because, again, most people are shooting for 24 frames per second. So what they would actually do is if they were on a little animation stand, they would take two pictures of a single frame, right? So they would take like a traditional walk cycle. You would take like two pictures of someone like this and then move their feet a little bit, take two more pictures, move their feet again, take two more pictures. So that's animating on the twos where you're basically just taking two pictures for every frame. That ends up being 12 frames per second. Like here in the digital world, we don't necessarily care about always being 24 frames per second because we can kind of set the frame rate of a video. We don't need to worry about being consistent as long as the media can be played via a video player, that sort of thing. On the threes is less common. On the twos is the most common. On the threes is a little less common. That's for cheaper animators. Commonly, like you'll see that in like anime, right? Where like some stuff doesn't move at all, but like just a little bit of a hand moves or that sort of thing. I was even seeing recently when the newest Spider-Man Into the Spider-Verse came out, a lot of animators were talking about how like different sections of those films were shot at different speeds, and even some frames or different scenes of those frames were shot where like some things were moving on the twos, some things were moving on the threes, and some things were literally moving every frame. And that's kind of more of an effect than it is really like a purposeful decision. Like you just get kind of an interesting effect when certain things move every frame and other things move every 3 frames. But it was fascinating to see that, like, even in a world where most stuff is still being made digitally, there's still some idea of these sort of concepts. Um, so what I would generally recommend for us is like 8 frames, 12 frames tends to feel right for these pieces. And the reason for that is like in a lot of cases, we're gonna have big jumps between our frames, right? We're not gonna generate a new image at every like frame that we would in video. It's just like kind of it's gonna be cost effective for us to not do that. So my general rule of thumb is the larger the gap between like visual difference in the frames, the slower the frame rate should be. So in general, that means stuff like 8 frames per second tends to feel right to me. You might want something like 10 or 12, or you might have big gaps in your images and you might want something even slower, like 4 or 6. And that's ultimately reasonable and it's kind of up to you. But my rule of thumb is just like the bigger the gap is between the similarity in images, the slower the frame rate should be because it's going to allow your brain to kind of process that. And then I should also mention, again, we kind of talked about this on the twos and on the threes, but like digital video doesn't really allow for multiple frame rates. So I think some of us were talking about how we like that sort of effect of having um, things move quickly and then stop on an image and then move quickly again and stop on an image. In order to do that using a fixed frame rate, you don't actually like say, okay, this section is playing at 5 frames per second, and this section is playing at 1 frame per second. You actually kind of have to create multiple images. So your fixed frame rate might be 12, and then one image is being held for 12 frames. And then you're doing like a bunch of sequences where it's 1 frame each in that 12 frames per second, and then holding again for 12. So this is kind of where it gets challenging. You need a tool like After Effects or maybe Premiere. I think maybe Premiere would allow you to sort of hold images for longer. But generally, you always have a fixed frame rate. There are variable frame rate videos, but that's kind of a different concept. It's not really meant for this kind of stuff. So in general, you need a fixed frame rate. And then when you fix that frame rate, if you want to do stuff where images are holding or that sort of thing, you would need to manually make those frames duplicated. I've got one like kind of hacky, crappy tool that kind of looks at stuff like that. That if you'll want to, they can explore that this week. I do a lot of frame rate changes in my own films. This is one from actually this is from back in 2020. The name here is wrong. But you see this kind of effect of like moving fast, then stopping, a lot of these sort of rhythmic sort of effects. And the tool I'll show you today is actually one I built in order to do this. So this is one example. And that was built using this tool called Vidum, which you can get from my GitHub here. I've got a little tutorial video for anyone that wants to play with it more. And there's a Colab notebook, which you can also run things through. I'll talk a little bit more about Colab later, because again, I wasn't planning on teaching that this week, or in this class, but for anyone that's interested, I have a ton of resources around Colab. This is a pretty rough tool. I built it literally to make that video for myself, and I've kind of updated it maybe in a year or two since then, but haven't really touched it much since then. So if anyone wants to give it a play, please feel free. And if there's anything super messed up in it, like I'm happy to fix it. But if you're also like, I really want these other 5 tools, I'm probably not adding anything new to it anytime soon, unless it's pretty simple. So just beware of that. The way Vidum works is it essentially works like pattern matching and pattern layering. So in that tool, you kind of define these patterns where it reads through a series of images. And based on your pattern, it kind of decides, okay, let's do 1 frame each of that pattern, or let's do a different sort of pattern where it might go through, hold an image for 2 frames, then do 1 frame, 1 frame, hold again for 2, 1 frame, 1 frame. And then you can kind of build that up into these other sequences. So you can kind of then add like pattern 2 plus pattern 1. So basically it looks at a folder of images and it kind of goes through that sequence and it kind of applies it based on these pattern rules. And that allows you to do some of that image sequencing stuff. The challenge is it doesn't ever there's nothing smart in it. It just literally says, here's the sorted folder of images, run through it in this sequence. So if you're trying to do sequencing on top of this, it might not work as well as you would think. So it's a cool little tool. You're welcome to play with it if you like really rhythmic editing. It's definitely a common thing in experimental film of like people creating these sort of rhythmic patterns with flickering images and that sort of thing. So I kind of built like a digital version of this to try this thing if anyone's interested in it. There is a tutorial video. All this is going to be linked to in the syllabus by the end of tonight. There's a syllabus on basically how to like turn a bunch of video stuff into individual frames and then recompose them using this Vidim library. And there's a Colab notebook for it as well. So you don't need to install anything locally in order to get it running. Um, but yeah, I would say just like if you're really interested in this concept, watch the videos. And then if you have questions, Q&A time is great for this, or DMing me over Slack. The next hour is going to be me just like pointing you to tools that I've already made with some tutorial videos. And you can just sort of decide like if you want to try them yourself, or if they're not for you, then you can skip them. This is another video I made. This one I finished up this year. Um, and this is pretty much the similar kind of concept, but it's less like individual patterning. And it's more like using variable frame rates to sort of map. There's a song. If you listen to the song, you'll hear there's like fast and slow parts. And based on the fast and slow parts, I sort of set different frame rates. So this film actually runs at 48 frames per second. But within that, there are 48 frames per second sections. There's 24 frames per second sections. There's 12 and there's 6. One of the things that can be kind of funky is if you have like let's say a frame rate of 30, but then you want to do a 24 frame rate second piece inside of a 30, it gets weird. You have to like double every sixth image or something like that. Every sixth image? Yeah, every sixth image. So setting your frame rate to be flexible is kind of an important thing. That's why a lot of people do choose 60 because it divides up quite nicely into other dimensions. So feel free to watch this one with the sound on. You'll see we're starting to do faster sections here. But again, like I think the frame rate is an interesting concept, especially when you have still images. Like this was made all using contact printed film where like there was no animation. So I'm kind of making up the animation by flickering things or by moving through sequences at slow and fast rates. And that's kind of the goal of this piece. And it made sense to kind of play with frame rate as a way to play with speed as well as the type of animation you see. So we've talked a little bit like how you could play with frame rates, even just thinking of a consistent frame rate, but how do you actually sequence your images, right? For those of us that are making stuff in Midjourney, you might have said like, oh, it'd be nice to have this image next to this image. And maybe you go in and just, if you only generate 40 or 50 images, like manually choosing like, okay, this one first, this one second, this one third, that sort of thing. But when you want to do that at scale, or when you want to sort of play with like more than 50 images, you kind of hit a point where you're like, I can't sort all this myself. So I'm going to go through a couple like different tools and techniques for ways to approach sorting and sequencing images that rely on other tools rather than just you manually doing it. I should also mention this is a whole class in and of itself, and I'm giving you the very, very abridged version. In 2023, I taught a class called algorithmic filmmaking that was essentially this. It was taking a bunch of video clips, sorting them according to different tools, and then recomposing them and remixing them. That class, all the YouTube playlists, all the videos from that class are on YouTube. There's probably like 20 hours of material for that if you're interested in that. This tends to operate more on like the scene level of a film. It's like the scene or the clip level, but a lot of it is still applicable to individual images as well. So, if you see something in there that's like more about pose detection across a person dancing in an image, that could also be applied to images. It's just a little bit kind of a change of thinking about how you work with stuff. So, that whole class is there. Please feel free to watch anything. If you need any recommendations, I can point you to any particular weeks. In fact, I'm going to show a week or two from that class here. But yeah, there's a ton of material there. I just also mentioned I have a 4-week FFMPEG class that we'll actually talk about as well. That gets into really crazy FFmpeg stuff. But so I've got a bunch of other classes on YouTube if anyone wants that material. So again, a lot of the notebooks or a lot of the tools that are packaged up and I talk about here are in what's called Colab. Colab is a notebook. It's like a Python notebook that runs Python in a cloud system. Um, Basically what that means is that there's a lot of command line stuff in there, but all my notebooks are kind of written where like you don't need to look at the code. You just need to know what to do per each cell. So a lot of these are accompanied by a tutorial that sort of says, okay, now like copy and paste the path of your folder into this cell, now run this cell, that sort of thing. So The hope is that you can use a lot of these tools that do require some coding knowledge without actually needing to code any of it yourself or like copy and paste stuff. It's just like pressing play and then sometimes copying paths around. So if you're interested in Colab, there is like a whole class on Colab. There's also this 1 30-minute video on just like what is Colab, how does it work? And that should give you enough to like play with the tools you're going to see from here on out. For many of you in this class, okay. Yeah, so now we're going to finally get into sequencing images. Most of the tooling that I use under the hood uses this tool called FFmpeg. And FFmpeg basically is the like Swiss Army knife of video tools. Like most of the video tools that you probably use have like some front end, like a UI, a UI, a GUI, a UI that sits on top of essentially FFmpeg. FFmpeg is like a classic, like everyone uses it under the hood, but it's also one of the most annoying and hard to understand like languages, if you can call it a language. So again, I do have a 4-week class that I'll add a link to in the syllabus of like how FFmpeg works, how it thinks, and doing weird stuff with it. But the most basic stuff that we're going to do in this class is just take an image sequence and then turn that into a video. And obviously you can do that with other tools, Premiere, Media Encoder, other things. But I like using FFmpeg for a couple reasons, which we'll see. I had posted in our Slack channel that you can install FFmpeg locally. If you're on a Mac, it's very easy. There's a couple different options. If you're on a Windows, it's a little bit trickier, but still quite easy. Or you can use Colab. So all the notebooks that I have here will basically run under the hood, will end up with FFmpeg. And you don't even need to use any of your local stuff to run that. And if you have a Google account, the versions of the notebooks that we're going to run or like that I'm recommending you run don't require any subscription or anything because they don't require a GPU. Another key attribute or thing to think about is that I don't know if anyone's downloaded all their images from Midjourney, but Midjourney added like this crazy long file name that has no sequence. It might have a timestamp in it, but it's like there's very little data in there about like when you made that or whatever it is. My preference for all of the video tools that we use, I try to generate like numbered sequences, and those images should be numbered using what we call padding. So this is, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 100. You'll see these are padded by zeros. And the reason we do that is because if you don't pad these with zeros, some programs will read 1 and 10 as next to each other because they both start with ones. So this sort of reinforces that these sequences like 0, 0, 0, 0, 1, 0, 0, 0, 0, 2, that sort of thing. So we actually like, I'll do a quick little demo on using FFmpeg. But essentially what we really want is our images in this order. Now, we don't always have to be, and I'll show an example of how to do that using basically, if you just download a folder of Midjourney, you could run FFmpeg to just sort all your images in there by like alphabetical and run that. But when we start to get to wanting more control, it's always good to convert our images into numbered systems like this. So if you're going to do it manually, you could literally go in and go, 0, 0, 0, 1. A lot of the tools that I work with are basically ways to convert a random set of images with weird file names into the sequence. So let's do this. I'm going to jump to Colab really quickly and do a really quick demo on how FFmpeg works. But there are basically 2 or 3 like lines in here using FFmpeg that you're going to want to remember or like be able to copy and paste essentially. And the first one is, so basically like, again, it's getting a little bit deeper than I was hoping to get to in this class, but there are codecs, right? So there's like H.264, which is commonly .mp4 for a file format. Then there's ProRes, which some of you are probably familiar with. ProRes is like a nearly lossless format, which is probably going to be better for our animations because you'll find that like the compression that happens with an H.264, you'll kind of lose your image details because your images are not super similar to each other. So there'll be a lot of compression artifacts in those images. So I'll show 2 examples, then we can talk about like what we need to do there. So let me just jump over to Colab really quickly. And again, you don't need to know anything about Colab. I'm just going to use these as an example of like how these tools work. So Colab is basically an interface that allows you to write command line, which again, most of you won't need to know. All I'm going to do is I'm going to share a notebook with you, and you can just press play whenever you want to run these tools without needing to learn the code. So as I mentioned, the other thing about this is it can connect to Google Drive, which is nice. So if you are like a good big Google person, like I have a whole 5 TB file in Google Drive or storage on Google Drive and connect those pretty easily. I won't do it for this demo, but there are other videos I have where that does happen. So this is like a file browser. So I'm gonna create a new folder in here and I'll just call these input images. And then I'm going to upload some images. So I'm just going to grab some images from my folder I made last week, which is already all the way down here. So I'm going to grab a handful of images and just upload those to Colab. So first things first is I have a bunch of images and you'll see that they've got no sequence to them. I meant to write this code earlier, but I didn't really. So I'm going to see how well Colab's AI generative code works. So let me just try this really quickly. So convert folder of images to image sequence padded with 9 zeros. Let's see if this figures out how to do this. If not, I can figure out how to write it really quickly. Perfect. Okay, cool. So what I can do here is, I think this will work. Let's just find out. So you can copy the paths of your files here. If you just right click on your folder, hit copy path, and then I'm going to paste that in here. Tonight I'll make this a little bit cleaner. I'll actually just add like a little GUI for this. So you don't have to find the line of code you need to update. There'll just be a little input text field that says like input image, input folder, output folder. And I'm going to make an output let's see. Let's make an output folder. Okay. So hopefully this works. Let's just see. Let me just look here real quick. Okay, I think this will work. Yep. Okay, so again, you don't really need to worry about this part because this is just more like a helper function for me. Basically, what this will do is this will read in all of my images and it will rename them essentially into this sequence that is helpful for me. This will basically just make it easier for us to write a couple FFmpeg commands, but I will show another command in FFmpeg that'll allow us to do this input folder as well. I just let this run, and while this runs, oh, it's done already. Okay. So the main thing for FFmpeg is basically you kind of build up this like path from like where you're starting to where you're ending. So I'll basically, again, I'll make a little UI for us. So the things we want to change are the only things we need to change for this. So I'll do that in just a second. But essentially what we need to do is we need to feed our image sequence into FFmpeg. So that uses the -i command, which is for input. So I'm going to take this folder path, which has all of my images sequenced, copy path, paste that in. And then what I want to do is I want to grab this. Basically, I want to be able to assign this a variable. And the way to do that, and again, you'll just learn this, or like I will help basically solve this for you, is this little command. So %09d says look for a 9-digit number in the order that you want it to be in. So basically, this is going to run through sequentially any image in this folder that is 9 digits and then a .png. And it's going to basically sequence according to that number. Next, I want to set a frame rate. So to do that, you do -r. So this is the frame rate. So I'm going to set a frame rate of 8. Could kind of do whatever. The other parts that we need here, again, these are just like, don't worry about them. Like we will basically like, I will hide some of this for you to make it as easy as possible for you to use. We have a codec for our video, and we're going to use a codec called libx264. And then we have a PIX format, which is YUV 420p. This is like a color thing. Basically allows me to open these videos in QuickTime. If you don't use this, you have to open it in some weird open source program. Lastly, what we want is we want an output. Where do we output this video? Or like, what should the file be called? So what I would do, again, in Colab, like this space here, this file browser here is called /content. And then we just want to give the video a name. So I'm just going to call it H264 animation.mp4, and then I can run this cell. If you're like, I am never writing this, I totally understand. Don't worry too much about this. I'm going to make this as easy as possible. And literally in the notebook everywhere else, this will be obfuscated away so that all you need to do is point it to the folder and your output name, and it'll figure it out from there. So like, if this is like way too much for you, I totally understand. I just want to give the very basics, and then we'll skip to like the fun stuff after this. So that is how you do a H.264 video. To do a ProRes video, all you do is you change a couple commands. And again, all this is documented here. So the thing I also want to mention is for your input path, you don't always need to use 4 digits or 9 digits. You can kind of do whatever. Oh, this is wrong. Okay, cool. So if you do 4 digits padded, which is also a very common thing, all you need to do is change your variable to be %04D. This says, 4 digits. This says 9 digits. Again, the tools that I have will basically do that for you. And as long as you follow the path of those tools, it'll know what to look for. ProRes is a little different. All we need to do is add in some different codec information in the middle of this. So what I'm going to do is I'm going to create a new code cell here, copy this in, and let's just actually do this. Copy all this, paste all this. So for a ProRes video, what you'll need to do is replace this stuff with this. For those of you that know about codecs, ProRes comes in a couple different flavors. There's ProRes 4222, there's ProRes HQ, whatever. This is ProRes HQ. And you get that by, there's this variable in here that says profile version or profile V, and it's 3, and that's the HQ. I just end up Googling all this stuff, to be honest with you. And then we just want to change our output name here. So we'll call this ProRes. And if you hover over these files, you'll kind of see how big they are. So this is 1.29 megabytes for the MP4, which is the H.264, and the ProRes is 8.6 megabytes. So ProRes is much higher quality, and therefore the file is bigger, even though all the images are the same size. When we actually download these and we look at these, I'll put these in a folder for people to review. I guarantee you that there's some weird compression on the H.264 because of how the video codecs work. Like they try to make things fluid between images because that's how most videos are. They have motion between them. Because we have no motion between our video clips, it's going to do some weird compression stuff. So in general, I think ProRes is better for animations. This comes down to file size limits, like other things for you. But just be aware, like I generally prefer ProRes for animation because it has less compression between our frames. The last thing I wanted to show is, let's see, do I have it here? Oh, I bring it up later. So let's just skip to it now. Sometimes you just don't have a way to output the sequence of images, right? You just want to be like, I've got a cool set of images and I just want to sort by alphabetical, or like maybe you name them A, B, C, D or whatever for some reason. There is a way to do that directly in ProRes and FFmpeg. There is this file, which is using this thing called pattern type glob, which is just like basically instead of looking for the digit pattern, it just sorts by sort of alphabetical or by whatever the file type is. So to do that, let's add this, let's copy this one here. Let's call this ProRes HQ glob pattern. So to change this, honestly, just keep a list of all these things and copy and paste all the time because I can never remember all of them. So you have to start with this thing, which basically just says I want to use the image demuxer. Again, crazy stuff. I'm going to copy this pattern.type.glob, and that goes after my input. The other really important thing for input in this case is you want to wrap all of your string in actual quotes. And then in this case, all of my images are, I believe, PNGs. Yeah, all these images are PNGs. So when you download an image from Midjourney, it's a PNG. So let's go put an asterisk in there. And all that's going to say is like, look for any file that matches this pattern. So any file that has a file name, whatever the file name is, with a PNG extension, will then be run through this pattern type glob to basically sort this stuff. And then, is there anything else I need to add here? No, I don't think so. That's it. So I'm going to run this. And you know what? I put in the wrong folder name. This folder, so copy path. Could find no file with path content images. An index in the range of 0, 4. I didn't ask you for an index. What's going on here? That's interesting. Does pattern type glob have to go in front of this? That's what it is. Hold on a second. Okay, I need to update my notes there. Cool. So sequence or order of operations matters here. Pattern underscore glob has to go in front of your your input, which makes sense. Cool. Okay. Okay, that is the only code you'll see for the rest of this class, I promise, or at least the only code you have to write in this class. And basically what I'm going to do tonight is I'll clean up this notebook and just share it with anyone so that you just have access to it. If you have FFmpeg installed on your own computer, if you went through those steps to install it, you can do the same thing directly inside of um, your own command line interface. So just open a command line. And you can literally copy and paste these commands, but skip the exclamation point in front of them. So if you have your own files, you could essentially run this yourself. Now, the thing is your path is going to be different. What you'll need to do is actually, let me come here. Let me grab the glob one. I can match this exact same folder because I have this folder here on my local computer. So if I just press onto the folder and hit Command C, and then I can come into this section in the command line and paste this in. Oh, that's why I can't spell. .mov. So you can run that exact same command locally. You're just going to change the paths, which again, doing that in a command line interface in terminal is not the most fun. I would generally say if you only have a handful of frames, using the Colab notebook might be easier for you. So sorry, that was a little bit deeper than I necessarily wanted to go, but that's just some basics. And then what we're going to do is we're going to look at some other ways to use these tools that are less basic and move a lot more like user friendly. So that's just like basic understanding if you want to understand what's going on behind the hood. But now we'll kind of move into some tools that like will hide some of that like annoying code and make it a little bit easier for everybody. Okay, so also I do have 1 or 2 videos here of things not that you don't have to do by yourself in a command line interface or in a Colab notebook. So again, ways to sequence stuff. So I tend to use a lot of randomization. I'll drain a bunch of frames and then randomly shuffle and sort those images. So this is quite good for what we sort of did this week, right? Which is like these sort of moving hold, cinemagraph things, and being able to do that randomization randomly, like just randomly picking images, you get sort of some nice effects. I have a video here for anyone that's interested as an After Effects user that basically allows you to import all of your images as layers, and then you can load in a script that basically randomly reshuffles your layers. So if you are an After Effects user, that's pretty good, and it's helpful to do that. I do a lot with this myself. It's just a script. One of the nice things is I don't know if anyone's played with Claude or ChatGPT yet. Adobe has like a really wonderful scripting engine that is impossible to learn because all the documentation sucks for it. But Claude and ChatGPT are actually not that bad at writing After Effects scripts. So, or in Adobe scripts. So if you're a Premiere user and you're like, hey, how would I do this in Premiere? You could ask ChatGPT to generate a script, a .jsx file that is an Adobe script that you could then load using Premiere. And they are they're not always perfect, but they will generally do what you need it to do. So if you haven't tried that before, like definitely like try it out. I'm a big Adobe user. I use a lot of their scripting tools because it allows me to make some powerful stuff. So if you are interested in that sort of world, like definitely let me know. I'm happy to send you more resources or like try to help with a thing. But I also do a lot of programming, so I kind of know what's going on in that space. But this is a cool little thing. And if you're more of an like a GUI user, like this is kind of a helpful space to think about. So randomization, just picking images at random is a great tool. Again, we talked about this a little bit, but like ordering by alphabetical or by creation or by download is very easy to do with FFmpeg tools. So if you like what I was kind of doing is I was downloading images from Midjourney as I was making them for that second sequence. And it kind of downloaded in an order that was already sortable. Like I did that sort of thing where I was like, generate one image, generate a couple subtle variations from it, then generate a strong variation. And like I was just sort of downloading in sequence. And when I did that in downloading in sequence, I could use that glob pattern match to basically generate the video based on the way I download the frames. So if you do that and it works for the way the file names are generated, like works, then you can use that glob pattern matching command line to generate those pieces. And again, this is what it looks like. And I've kind of highlighted here in the red what needs to change from the other versions of the command. What other ways can we sequence stuff? Well, we could sequence stuff by color, right? So let's say you're generating, I don't know, different scenes, and like some of them are in like sunset, like sort of oranges and purples. Others are in the middle of the day and it's bright and blue. Like, what if you could just sort of sequence by like the color or the hue of a thing? There are tools that allows you to do that. There's a thing called k-means, which is actually like a data science clustering algorithm. This is kind of a visualization of how it works, which is that you drop random points in your sort of 2D grid, and then it sort of figures out what clusters belong with what. You might ask, how does this work with color? Well, color can be divided into hue, saturation, and value, and those are just numbers. So it's essentially a three-dimensional grid, but it's very easy to cluster using these algorithms. What that ends up looking like is something like this. So k-means allows you to take an image, and by kind of doing this cluster algorithm, you can end up with different color values that are sort of your main colors. So within this image, this k-means system kind of figured out that like, okay, there's this yellow, there's this maroon, there's this sort of teal, there's a dark blue, and there's a black. And when you set k-means, you set the number of clusters. So in this case, it literally asks like, I want 5 clusters of the most predominant or most, I don't know if most predominant is the word to use, but most unique. Like what are the most separable colors within this image? So what we could do then is we could begin to sequence images based on that. So we could basically take every image in a series of frames and sort of say, what's the most predominant color in each one of those frames, and then sort by that. With quite honestly, like not the best results. This gets into some complicated stuff, but essentially, like this is a good example here where like, also I should mention k-means is non-deterministic, meaning it changes every time you run it a little bit. So you'll kind of see in this version, this is basically k-means has been run on this frame 3 times. And you'll see like only in this version did it pull out any blues. And these other versions, it kind of found more oranges and more greens. So there's kind of a little bit of like, this is not a science, it's more like a process. And it doesn't always lead to the best results. The other challenge is if you sort just by hue, for those of you that know color science, you've got hue, saturation, and value, right? So here's a good example of what happens. This is for the demo that I have a video for. This is technically sorting the most predominant color by hue. The problem is that when you think about hue separated from value, this means that sometimes you can have a black image. Like let's say an image has black is predominantly black, but has a little bit of red in it. Well, that hue might be red. Then the next image after it might be a white image with a little bit of red in it. The hue is still red. So the challenge with some of these tools is finding the right balance of like hue, saturation, and value. And there are ways to like weight things and then kind of do that algorithm. I would say in general, like this is a bit of a challenge and doesn't always produce the results you want. But that's going to be true of every one of these tools that we're going to look at. Um, Sometimes it's more like finding the right tool for the right image set you have. So if you have images that are all of a similar value, like actually the images that I was producing for Midjourney with had a lot of that red. If I had like that same sort of value or that same kind of tone, but I had other images that were blue and other images that were green, and then these images that were red, and I wanted to sort by sort of those buckets, that would work better than this sort of random, completely random set of patterns. And that's kind of the challenge with like colors is like colors are really multidimensional and like the way we perceive color is not the way necessarily the way that a mathematic algorithm perceives colors or that a mathematic algorithm thinks about colors. So in this case, like it can be a little tricky. If you are interested in playing with this, like if you do have a data set that is a little bit more even in terms of value and saturation, I put a video up here on how to basically sort by color. And there's a collab notebook that goes with it. And as you'll see, it's like literally like you just put in an input of your input folder and where you want the images to be output, and then you generate a video from that. So you don't need to worry about any of the code here. You just kind of follow along in this right-hand panel to fill that out. This video is 7 minutes. So, if you want to explore this and play with it, feel free to take a look at that. And then again, if there's any questions about those materials, I'm happy to answer them over Slack or in a Q&A session. All right, this is the one that people want to talk about based on what we talked about last week, which is buy visual content, quote unquote. And this will use an AI model that allows you to do this. There's sort of two different ways you can think about this. One is like, what is the actual visual content in terms of, is there a dog in this photo, which is more like a vision model, right? Like, do I see a dog in this photo? Yes or no? Then we've got this other thing, which is more abstract, which is what I tend to use, which is looking at visual structures. And that can mean both on like sort of the high level of like, are the circles in the same place, or like textural, meaning is it using the same texture in this image or is it using the same colors? These use models called LPIPs. This is an example that I used, man, all the way back in 2020. This was sorting a series of botanical flowers by however this model sorts things. And you can kind of see like I, as a human, do not know how it's sorting stuff. I can kind of guess. There are little sequences where I kind of see that things are like in a similar triangular structure. Um, this is kind of one of the challenges of these tools is that they sometimes see stuff that you and I don't see. Because of how neural networks work, they're built up in these massive layer systems, and the way that they combine things in these cases sometimes are kind of weird. Now, there's also a data set that's quite diverse. You very likely will have less images or animations you've made in Midjourney that have this much diversity, but it's something to just be aware of. For that film anime that I made, I also have a section of it that uses this process. And what I find kind of interesting here is this makes a little more sense, right? It's finding all the dotted images and it's kind of structuring them according to like, what sort of halftone pattern they have. Is the halftone in the same place? You can see there's a little bit of color sorting. It's kind of like going from red to purple, back to red to yellow. Like this one makes more sense to me. But what is interesting is sometimes there's these weird leaps where it takes a jump from one thing to the next, and you're sort of like, how the hell did it decide to do that? So let me scrub ahead a little bit more. Got a lot of dots in here. Okay, so this is like a structure where we've got everything sliced in half. Let's jump ahead a little bit more. So one thing to know about this model is what this does is it takes every single, like if you give it 100 frames, it's going to take all 100 frames. It's going to pick the first frame. Then it's going to compare that first frame to the next 99 frames. And it's going to pull out the one that is closest to it. It's going to say, okay, this one's closest to it, so this goes next. Then it's going to take that frame and look at the other 98 images or 97, I don't know, math, 98, pull out one from there and then use that. So what ends up happening with these models is the beginning of the sequence is very, very fluid. It finds the very, very, very close stuff, which is great. That's kind of what you want. You want that sort of fluid animation. When it looks at the very end, if I scrub to the very end here, you'll kind of see that it starts to get a little chaotic because there's only so many frames left for it to pick from. So it's kind of picking whatever it finds closest, which may not really be like the most accurate frame, but it's just what's left in the pool. So that can be helpful because you kind of get these different sections where I can say like, I want a section that's a little bit more chaotic or a little less chaotic, like that sort of thing. But these systems are kind of like set to like really be like they're going to loop through every single image first. So as I mentioned, I think this sequence, not this exact sequence, but other sequences like it where there were 4,000 frames, took about 3 days to process using the DreamSim model. The LPIPS model takes about a day. So this stuff is quite complicated if you have a lot of frames. When I was doing this for the Midjourney example that I made last week, where there's only 70 frames, it took about 5 minutes. So again, it's more of almost exponential. Like the more frames you have, the longer it takes because it has to do that whole, like it's going to look through every single image. Then it's going to look through the next set of images. So the more images you have, the longer this is going to take. The process for this is in this video here. No, this is me doing this on our that Midjourney data set. And the nice thing is you'll see that all it did, it was kind of picked up the similarities between certain images, right? So it picked up the subtles and sort of sequenced by the subtle. Then it jumps to sort of what it finds is the next in that strong, but it's still, you can see like when her face is turned one direction, it kind of picks up all those images that are that direction. So it does do a good job of actually kind of like finding similarities in the images. But when it chooses to go from here to here, like I'm always a little confused about like what it decided was making that connection. Maybe it was even some of the lights glowing behind the scenes that are similar or something. This is powerful because we don't have to do it ourselves, right? If you have 1,000 images, being able to sort these and sequence these according to a machine learning model is great. But if you don't agree with the machine learning model, that's kind of like you're out of luck. So there are two different versions. There's one called LPIPS, another called DreamSim. DreamSim takes much longer, but is probably slightly more accurate. LPIPS is about a third of the time, but it is faster, and I would say the accuracy is probably good enough. This video that's included here and also linked to in the syllabus, you can watch. It's about a 15-minute demo. It's very easy, very straightforward. And we'll basically use both those processes to sort your images and then turn it into a video for you. So again, if you're interested in this idea, watch this video. If you run into issues or have questions about it, please ask me over Slack or in our Q&A, and I'm happy to sort of walk you through this. This would be like my idea. Like I would definitely say like more than anything, this is probably the one that's going to get you the best results, but it takes a little bit longer to set up and a little bit longer to run. As I was thinking about this and as I was thinking about how to do content, I thought like, well, we could also ask a vision model, right? So ChatGPT allows you to upload images. You can upload images to Claude, to Gemini, whatever else. So it's kind of thinking about like, what if I want to just like find only the images that someone's eyes were open in, right? So in that Midjourney, I opened their eyes a couple times, that sort of thing. So it's kind of like trying to feed this to ChatGPT to say like, hey, on a scale of 1.0 fully open to 0.0 fully closed, how open are the eyes of the person in the photo? And I got bad results. So not the best example, but you could, depending on your use case, you could ask one of these vision models how to sort things or sequence things. This is clearly just an example of like one image response. To do this at scale, you would need to set up some other like API system where you're talking about it. I was trying to set this up with Gemini, but it turns out Gemini doesn't allow you to send images of people's faces. It just blocks anything with faces. So Gemini couldn't work for that. So you'd have to use ChatGPT or Claude or like an open model. If anyone is interested in this, I'd be happy to like figure out how to make a quick little dummy example. The problem is when you get to APIs, you're generally paying for all those calls, which means it can get expensive. I guess it could set up a notebook that uses an open source VLM, but those also tend to require a lot of GPU bandwidth. So this one is yet to work. Back in the day, 3 or 4 years ago, you'd have to train a custom classifier to do this. You'd have to find a data set of people with eyes closed and eyes open, and have to assign each of those like values, and then you have to train the model for a day, and then you have to like run it through the classifier. Thankfully, these vision models are way, way faster in that regard, but they aren't always accurate either. So there's always this hit or miss here. But if anyone's interested or has a particular concept for this, I would love to talk about this and like figure it out a little bit more. My early examples yesterday, as I was sort of running through those examples, just didn't work out. And I was like, let's put this one aside for a little bit. Okay, so that is a big deep dive into sequencing things. Again, if you have more ideas, more questions, please hit me up. At this point, let's take a little break. We'll come back and make some fun, trippy animations. So let's come back at 20 after, and we'll look at deform. Cool. All right, see you in a little bit.